Hi, my name is Nikhil and I'll be talking about a paper describing the CLIFER framework for continual learning with imagination for facial expression recognition. Let's begin. Facial expression recognition aims at developing models that generalize across contextual scenarios. Yet, for real-world implementation, these models need to be sensitive to individual differences in expression to personalize towards users. This results in a trade-off with personalization affecting generalization for the model and vice versa. Traditional learning focuses more on generalization by training on large benchmark datasets. Yet this generalization comes at the cost of losing sensitivity to individual differences. Adapting to individual expressions requires models to continually learn with new data while remembering past interactions. Continual learning of an individual's facial expressions can thus enable models to personalize towards different users. Here, we focus on complementary learning systems found in the human brain, where the hippocampus enables an episodic memory of experiences that rapidly adapt to novel learning. These experiences are slowly replayed to the neocortical semantic memory, enabling long-term storage and preservation of knowledge. We employ the growing dual memory, where the episodic memory is responsible for learning novel data encountered by the model. Its fast learning rate allows for rapid addition of neurons to represent feature prototypes. The semantic memory receives winner neurons from the episodic memory to learn overlapping representations. A histogram-based associative labeling scheme is used for classification, and new neurons are added only if current neurons cannot classify input samples. Optionally, at the end of each episode, neural activation trajectories from the episodic memory are replayed to both the memories to mitigate forgetting. For our implementation, encoded input samples are prototyped by the episodic memory and later replayed to the semantic memory. In real-world applications, gathering subject-specific data is a major challenge as interactions are limited. To solve this, we propose the use of imagination as a substitute to sensory input, where the model can simulate additional data for a subject by imagining interactions under different effective contexts. We propose the use of adversarial learning for such imagination, simulating additional training data using generative models. The input is first encoded into a latent variable, which along with the target label is passed to the generator that translates the input image to the target label. The model is trained in an adversarial manner using discriminator that plays a min-max game with the generator. For further regularization, the latent variable is also forced to be uniformly distributed and a classification loss is imposed in order to learn meaningful representations. Given the input samples and the target labels, the model is able to translate images for a subject to represent different expression class labels, generating additional data for the subject. So for each subject, input samples are encoded and passed to the episodic memory. The best matching neurons from the episodic memory are used to train the semantic memory, as well as passed to the generator to imagine additional samples representing different classes. These imagined samples are then encoded and passed back to the dual memory setup, augmenting learning for seen as well as yet unseen classes. To evaluate the model, we test its performance on 3 different datasets, representing acted as well as spontaneous settings encoding 6 expression labels. For comparison, we implement 4 different models, comparing a traditional learning-based MLP baseline with GDM models both without and with explicit pseudo-rehearsal, as well as our proposed CLIFER framework with imagination capabilities. For the first experiment, we evaluate a class incremental learning scenario, training the model one class at a time, evaluating its performance on all seen classes. We see for all the datasets, CLIFER on average outperforms all other models, with the closest competitor being the GDM plus replay model. To evaluate the model's ability to generalize to yet unseen classes, we conduct another experiment where at each step, the model is evaluated in all seen and unseen classes. For all the 3 datasets, we see similar results where CLIFER outperforms other models. The autoencoder-based imagination model allows it to generate additional data for each subject, implicitly replaying samples for seen as well as yet unseen classes to augment learning. Interestingly, class ordering significantly impacts the model's learning behavior. We compared model performance for 6 different class orderings, starting with each class once. The F1 scores for beginning and end of learning were compared across orders, resulting in a significant difference due to class ordering. Starting with neutral resulted in an overall increase in model performance. Neutral samples form a normative baseline for the model and enable learning distinct feature prototypes for subsequent classes. Thus, to sum up, in this work we presented a novel continual learning framework that makes use of imagination to augment person-specific facial expression recognition. We implement a complementary learning system that integrates new information without forgetting past. Imagination forms a critical tool to simulate additional user data in the absence of sensory stimulus. Further, we highlight how the class ordering impacts model performance and recommend starting with neutral to enable learning of distinct feature prototypes that improve model performance. Thank you so much for listening.